Good morning to one and all. Today, we are going to solve a simple problem on economic load dispatch of thermal generating units with considering B loss coefficient. Take down this problem. A system consists of two plants, plant 1 and plant 2, connected by a tie line, and load is located at the plant 2. Load is located at the plant 2. When 100 megawatt is transmitted from plant 1, a loss of 10 megawatt takes place on the tile. Determine the generation schedule at both the plants and the power received by the load. When lambda for the system is rupees 25 per megawatt hour, and the fuel inputs of two plants are given by F1 is equal to 0.015 P1 square plus 17 P1 plus 50 rupees per hour. F2 is equal to 0.03 P2 square plus 19 P2 plus 30 rupees per hour. So here, here the similar kind of problem already we solved some complex problem. This is one of the simple problem, like a 5-mark question they may ask. So directly given all the things directly given, what they have given is 100 megawatt is transmitted from plant 1 and loss of 10 megawatt happens in the line. So the power loss equation PL is equal to V11 P1 squared plus 2 V12 P1 P2 plus V22 P2 squared. This is the formula for power loss with the V loss coefficient with the matrix. So here given 100 megawatt transmitted from plant 1, that is given in the problem. So the load is at the plant 2. So if 100 megawatt is transmitted from the plant 1, automatically we need to assume that load is at the plant 2 because only two plants are there. So like that we need to assume. Okay, so it is say for example, the load is located at plant already given in the problem. So P2 will not have effect on the load. Okay, so P2 terms we are going to neglect in this B loss coefficient matrix. So PL equation becomes PL is equal to B11 into P1 square. Take this as equation number 1. So PL power loss already given as 10 megawatt. Okay, so here just you need to substitute PL is equal to 10 megawatt and P11 into P1 squared. P1 squared also given. So P1 also given because what they did is what they have given is when 100 megawatt is transmitted from plant 1, that is given. So 100 megawatt. So P1 is 100 megawatt. So P1 is 100 megawatt. Here you substitute P1 is equal to 100 megawatt. So 100 square. So you can find out B1. So B11 is equal to 10 divided by 100 square. So you'll get 0.001 megawatt inverse. Okay. So PL is given from the problem. Now, you need to solve, you need to calculate P1 and P2. So either two methods are there. As I previously discussed, you can solve this problem by using the lambda iteration method also or direct method also. So two methods I have solved. So I am explaining the like optimality condition, that is IC1 is equal to IC2 is equal to lambda. That is nothing but DF1 divided by DP1 is equal to DF2 divided by DP2 is equal to lambda. So DF1 divided by DP1 is equal to, so you need to differentiate the first fuel cost with respect to P1. So if you differentiate, you will get 0.03 P1 plus 17, that is equal to lambda. So from this, we can find out P1 is equal to lambda minus 17 divided by 0.03. So if you substitute lambda already given in the problem, as 25 per megawatt hour. So just you need to substitute this lambda as 25. So you'll get 266.67 megawatt. So similarly, what I'm doing is I'm solving with the lambda iteration method. Lambda iteration method, the formula you know for calculating PA. So PA is equal to lambda minus BA divided by 2A. So lambda already given in the problem, 25 you know. BA means B1 because P1 we are calculating now. So B1 divided by 2A1. So B1 you need to substitute, 2A1 you need to substitute. We are getting the same answer. So either two methods are there. So which method is very convenient for you, you can solve. I think lambda iteration method is a very easiest method than this method, because direct formula substitution, you will get the answer. If you're not able to remember this formula in the lambda iteration method, then you can go for this method, differentiation and equate it to lambda. That also you can follow. So similarly, you need to find out the P2. Here, what we are doing is we are doing with two methods. First, we are differentiating and equating it to lambda. So when differentiating, we'll get the equation as 0.06 P2 plus 19. So P2 is equal to lambda minus 19 divided by 0.06. Okay, so substitute lambda is equal to 25 megawatt. If you substitute, you'll get the answer as P2 is equal to 100 megawatt. Similarly, here by lambda iteration method, we are calculating with the direct formula. So P2 is equal to lambda minus B2 divided by 2A2. So here we are substituting all this value. We are getting the 100 megawatt. Same answer we are getting in the lambda iteration method. So you decide which method is easy for you. That method you follow blindly. Next, from the equation one. From the equation one, already we did know. So PL is equal to B11 into P1 square. So B11 into P1 square. So P1 we calculated. So P1 we calculated as 266.67. That we calculated in the previously. Okay, P1 is equal to 266.67 megawatt. So here we need to substitute P1 here. B11 already we calculated, that is 0.001. Like simplifying, you'll get like a P loss. Okay, power loss as 71.112 megawatt. Here, P demand is equal to P1 plus P2 minus P loss. That is nothing but PG is equal to PD plus PL. So PD is equal to PG minus PL. So PG is nothing but P1 plus P2 minus PL. So P1 and P2 we already calculated. That is 266.67 megawatt, and P2 as 71.112 megawatt minus this. P2 we calculate as 100 megawatt. So PL we calculate as 71.112. Just you need to substitute it. We are getting the demand as 295.558 megawatt. That is the power received by the load. So they asked what is the power received by the load. Based on the question, you need to determine the generation schedule that we calculated, and power received by the load. So power received by the load is nothing but the demand. So demand is we calculate as 295.558 megawatt. So what is the generation schedule? Already we calculated. P1 is equal to 266.67 megawatt and P2 is equal to 100 megawatt. So you need to take out the answer, highlight, and you need to highlight this answer. Then only, so evaluators, whenever they were evaluating your papers, so it is easy for them to identify the answers and steps easily. And sequentially, you just follow formula, substitution, answer, like that you do, means easily they will give 5 marks for this. Okay. Somebody, what they will do is just they will do very simple calculation. Like they will directly calculate P1 is equal to some answer. With the scientific calculator itself, they will calculate, and they will just write the P1 is equal to this answer, P2 is equal to this answer, PL is equal to that answer, and demand is equal to this one, like that. So blindly they will write only answers. So only answers means they will give instead of 5 marks, they will give half mark or 1 mark, like. So sequentially you need to do formula, substitution, answer, like that. So it will be easy for your evaluators to correctly award your marks. Full marks you need to get this kind of question. So don't confuse. First you read the question clearly. If say for example, so loss is 10 megawatt and they have clearly said 100 megawatt is transmitted from plant 1, takes place on the tie line. So it is like a loss equation only. P loss is given. So 100 megawatt is transmitted from plant 1. So sometimes power loss equation will be given. Power loss PL is equal to some equation will be given. So that problem also we have solved previously. Just go back to my previous videos, and that kind of problem also you can go through once. while solving this kind of economic load dispatch. Thank you.